All right, good to see everybody again this morning on this great Hawaiian day. We've got to come here and show the audience. I will at some point. Anyway, we finished on this one yesterday, and what I suggested for this one is to make a rewrite. G of x equals, and we can take this 7/5 and put it out here in the position of A, can't we?
Yeah.
So we have x minus 6. And what we agreed upon, Rindy and others, was that the vertex for this was the point 6 comma 4, which is analogous to the h and k. And so if we go to 6 here in 4, and so this will be our vertex, and we see the thing is positive, so we have the rise over run in effect of 7 over 5. So up 7, 2, 4, 6, 7, and 5. So we're looking something like this on this side. And then on the other side, we're going the other direction. 7 this way, 5 this way. So the other side looks like this. And didn't we set our calculators yesterday too to do this?
Mm-hmm.
Yeah. I'm gonna go set mine, or just get it fired up anyway. There we go. It'll come up here in a minute. But so are we squared away from yesterday here? Does that look pretty good?
Yes.
Okay, have you done number 4 yet?
Yeah.
Yeah.
Okay. So what is going to be our vertex here for number 4?
2.
So 4 comma 2.
Yeah.
Okay, and so we go to the right 4 and up 2, so it'll be about right here. Is that right? And what is our slope for this thing? 3, 7. So up 3. These are by 2's, right? So up 3 over 2, 4, 6, 7. So something like this. And then we're back this way. Now, I want to tell you something that happened in my other classes, or at least it was in 8th period class yesterday. It was Jade who said that this what is this 3/7? He says, oh, it's the slope. Well, yeah, it is, but it's not exactly the slope, because this slope equals 3/7 for x when x is what? Greater than or equal to 4. But what is the slope if x is less than 4? Negative 3/7. Thank you, Marcus. Negative 3/7 when x is less than 4. So yeah, it is a slope, but it has that characteristic.
Mm-hmm.
Okay, any questions on that? Did you graph this in your calculator, everybody?
Yeah.
No? Yes. You make sure I got a calculator going. Check for notifications, no. Okay. And I think what happened yesterday, I'm not sure if we might have played the video for this class. All right, let's go to next one here. This one. Okay, have you done this one? You have. Who can help me with this one? Jose or Cheyenne or Chloe or Lexi?
Vertex 2, 3.
Negative. Vertex 2 negative.
Okay, vertex. Okay, a lot of you've helped me on that. Thank you. Vertex is going to be the point 2, negative 3. And so we can go mark that 2. Looks like we're going by 1s here, right?
Yeah.
So does that look right?
Uh-huh.
Okay, and then what about our
So,
7 and 4, so 1, 2, 3, 4, 5, 6, 7, and over 4.
Mr. G, it's counting my twos. I mean, just kidding, I'm so dumb.
No, the other, see, here's the tricky thing was, you gotta watch for that, because the other ones were counting by 2s, right? And this, I think, was the first one that counted by 1s.
yeah.
And so I'm glad you brought that up, because that's one thing you gotta watch out for. So don't be embarrassed by that. It was a good thought. That's what the good students do,
Look at
right?
my skin.
Little girl, tell them we still love you.
I burned myself on tomatoes.
Yes, so why is it
Because
I'm pretty much
this.
up 7.
Okay, look, it came out of the microwave, and then
Yeah.
That's a lot, it's like,
3.
and then it burned me.
So when it came back, you went
That's
down
7,
2,
1,
3,
2.
4, 5. No.
3,
So-
4, 5, 6, 7, 4.
You ever raise your hand on the stove that was on?
So something like
Yeah.
this.
Gonna
If
cry.
you're on
Look.
day,
When I checked my
not the
flat
other
out,
day.
Yeah, we-
I ran my whole thing around.
You know?
That's when I really
What is it about?
actually grabbed it.
Huh? Did you read it? Kinda.
Okay, so that's it, right?
You did?
Yeah.
Kinda. Like,
There's nothing more to this one?
No.
No.
Huh?
Okay.
Weird, yeah. Just start saying I.
All right.
It's not like you're slowly doing it.
I just starts making
Now-
sense. Yeah.
It's like when I'm brushing
Right.
out, it's good to
So now-
make sure it's not on when you leave.
So now for these ones, 6, 7, and 8, graph the given function and identify domain and range. And so for this one here, you're looking at this. What kind of function do we call this one for number 6? What do we call this? The what?
Parent function.
The parent function. Who said parent function?
Me and Chloe at the exact same
All right,
time.
very good. So this is this is parent function.
And Sadie.
So our domain for this guy is gonna be, what is our domain for this guy?
Negative.
It's positive.
Negative infinity and positive infinity.
Hasta infinidad, okay, and the range, 0, bracket 0 or parentheses 0?
Bracket. Well, yeah, bracket.
Bracket.
Oh, yeah, it
Yeah, it does actually touch. Okay, and this is interval notation, and of course, there's set, you may need set notation, or it doesn't really tell what it is here. Okay, now, this one here, what's gonna be our, what is this gonna look like here? 5, 7? So, and it looks like we're going by, what are we going by here? 4s. So 5 is gonna be about here, and 7 is gonna be about here maybe, is that right?
Mm-hmm.
And what is our slope, 4/3?
I'll go by 4 is what it is. 4, 8, and then it skips one, it says 2.
Really?
Wow.
4, 8,
Operation mark.
Oh, yeah.
oh yeah, that's
I didn't
right,
even
it's
know
a
that.
misprint actually. Because this should be 16, right?
Yeah.
Yeah.
Oh man, this is, gosh, there are
Marcus
errors
gets
in
a
the
gold
phone.
star.
Yes.
In the book, man.
Because the
Good job, Mark.
shining star.
No.
My gosh, yeah, the book, what happened was, the text writers, what they did is they made sort of a workbook for actual students to get the book and actually to write in it, and they just changed that into a textbook, and so it's not finished out like a properly in a lot of instances.
Yeah.
And even well-written textbooks will have occasionally have errors in them. Okay, Marcus, you might have a career
Maybe.
as a textbook writer. Okay, so anyway, we're 4/3, right? So we're starting here, then up 4 and over 3, and it's hard with these being 4 apart to see exactly, but it's gonna be something like this maybe. Does that look right? About,
It's perfect.
yeah, and then like this over 3 this way, so something like this. And then our domain. What was our domain for this guy? Same thing. And our range is gonna be,
8.
7.
Yes.
7, right? So 7. infinity, right? So now we're looking at that 8. What is this one gonna look like? 2, comma 0, so like right here. So vertex, I'll put vertex. 2, comma 0. And so right here, and what are we gonna do with our A over here?
The what? Oh, the go down.
Go down 7, Marcus says, go down 7,
To the left 6.
and then, yeah, to the left 6, or I'm gonna go to the right 6, and we'll use the slope, but yeah, Marcus is right on that too, I think. So 2, 4, 6, right? So the thing's gonna look something like this,
He's staring at me. Why do you think he's staring at me?
and then the other way, right, Marcus? So 6 this way too, so right here also. Okay, our domain is gonna be, what is our domain? Same thing, right?
Yep.
What is our range gonna be for this?
Infinity.
Big infinity up to 0. Okay, so really that's gonna be it for that one. Wow.
Great.
Not too hard.
Yeah. No, not really.
Okay, let's go on to these here. It's gonna be the same type of thing for these. But we can actually, can we take these things and put them outside?
Yeah.
Yeah. So it's gonna be the same sort of thing. What is our vertex going to be here?
2,
2, -7, and we're counting by 2s, right? So 2 and -7 down like this. And then we have our rise and the run. 3, 4, is that 3, 4 like that? And then 3, 4 the other way, up 3, 4 the other way will be right here. And our domain is going to be same as we've seen it. And range is going to be -7. What I want to do is, this one here, 10 should be pretty easy. I want to go ahead and concentrate on number 11. This number 11 throws kind of a curveball at us. I don't know if you, what do you think for number 11?
That's supposed to be negative 7/3?
That's -7/3 here.
With the vertex be -5,
So Marcus says our vertex is going to be -5, -4, is that right? So that would be, these are by 2s. So -5, -4 would be about right here. Okay, what do we do with this thing, this -7/3?
Take it out.
Are you?
You get rid of the negative?
Are you just not?
Okay. Why does the thing become positive here if we rewrite this
Because
thing?
it's in the absolute.
Yeah, it's in the absolute value. So this one is really going to be 7/3 x plus 5
Mr. Chairman,
minus 4, yes.
if, so if a positive 5 is in there, it would turn to a negative.
Yeah, and the reason is, well, you mean this thing here? No, this thing would stay the
What
same.
about the 7/3?
Well, This thing would stay the same, but this thing that multiplies by x. But you know something else that is happening that I forgot to tell you? No, that is right.
Vertex B.
So it was already positive.
That actually is right. I was gonna say something that I
Okay, so the equation, you have to.
So if we graph this thing-
subtract the number that's there. So if you subtract a negative number, then it makes it positive. So if you subtract -4 from 0.
I see what you're saying though.
It's
If
bad
the one's
for it.
positive, it doesn't turn to a negative.
It's just like,
And the thing that we have that's fortunate is we can actually test this thing with 7/3, x plus 5 minus 4. Thirds. So, oops, 7. Let me try this. 7/3. Thirds, I'm just gonna do it the way they did it. X plus 5. And then put over here -4, is that right? And see what happens. Yeah, that's exactly what we thought would happen, right?
Yeah.
So up 7 over 1, 2, 3, 4, 5, 6, 7 over 4. 1, 2, 3, 4. 7/3, it's over 3, excuse me. Yeah, up 7, 2, 3, 4, 5, 6, 7 over 3. 1, 2, 3. Yeah, checks out. So up 7, 2, 4, 6, 7 over 3. So go like this. Over 3. Okay, and this one here should be pretty easy. You probably already did that one, right?
Yeah.
Okay, now we have this one. Write the absolute value in this form here. So here we're given a situation where we have a graph, and we're trying to work backwards to find the equation given a graph. So this requires another level of analysis. But we're given a vertex to start out with, right? So what I recommend doing, it does say let A equal 1. Oh yeah, because what they're trying to do is they're trying to get A and B. What I'm going to do is I'm going to change this. I'm going to say find A, we'll say let B equal 1. I want let B equal 1. So I've changed the nature of it. Because I'm looking for this sort of thing here. That's what I'm looking for. What is A going to be? You understand what I'm doing, right? You don't? No. I'll show you. Okay, what it is what is our vertex here for this? Vertex is -7, 4. So what we're going to get is A, f of x is equal to A times, so if we have h equal -7, what are we going to have here?
Plus 7.
X plus 7 plus 4. Okay, and now we're going to find what A is, what do we do? What can we do?
-4 from both sides.
So we have this other point here, right? Can we use this other point to figure out what's going on?
Sure.
Yeah, so what do we do at this point here?
Negative y2, or y2 minus y.
So we take, what is the y value here? 6, right? So we're going to take 6 is equal to A times, what is x? -6. So we'll put -6 plus 7 plus 4. And now can we solve for A? Yeah. So we have 6 is equal to, what does this simplify to? Negative 6 plus 7. 1. So 6 is going to be A plus 4. So A is going to be equal to what? A is equal to
I mean, 2.
2, right?
I'm just like.
So what that does, it gives us an equation of f of x is equal to 2, and we're going to have x plus 7, and then outside here we put plus 4. And the last thing we can do is we can go test to make sure that's what it is, just recognizing we have the points here. So we go to our calculator, we have, erase this, we'll go for magenta color, so 2, absolute value of x plus 7, is that right? And then over here, we put, is it plus 4?
Yes.
Yeah, and then we graph and see what it looks like. And so if it's right, we should see the right, we should see at the table, I don't know, it doesn't work well. Go minus. Yeah, so that's right. So these 2 points are included, so that proves that we have a good equation here, okay? Now I want to go ahead, they were saying let A equal 1 and let B be greater than 0. So if A is going to be 1, that's going to have to be 1/2, I think. Because what B would have to be 1/2, but the way we did it, the way I recommend it was like this. So what I want you to do is similarly work out number 13.
What are we finding on 13?
Pardon me?
We're doing the same thing as.
Yeah, I would. Now, one thing you're gonna have is, you are gonna have, A is gonna be negative, right? Outside of the bracket here. So go do that. And while you do that, I'm gonna go over and mug for the camera here. It's a Hawaiian day.
Your microphone wasn't plugged in.
Oh, isn't plugged in?
I don't know.
What it is, it's actually working, but it's going off the camera mic and not the boom mic.
Should we all get up and go show the camera?
So it'll be okay. Everybody still be, thank you for noticing that. So anyway, hello, happy Hawaiian Day, everybody.
G-Dog.
Yeah, then we don't need this battery working either, do we? Yeah, the audio is gonna be a little bit better with that microphone instead of the camera microphone, but it still will work. Okay, where I'm located, so it didn't totally ruin the class. I hope. If the class got ruined, it was other stuff that ruined the class. And I think what we're gonna do for this class, I think it'll work really well just to leave it at number 13, and then we can pick up on 14 through 19 on Monday. Okay, has anybody finished this yet?
No.
Randy, you finished it? Other people are still working. Let's give them a couple more minutes. Let me get rid. Lexi's checking with her calculator.
Go up, Lexi.
No, it is. Lexi, are you a calculator expert? She's no, she's very humble, very modest, shaking her head no.
Cat.
Oh, let's see what you guys.
Does anybody here admit to being a calculator expert?
Russ.
Randy?
Or Randy.
No, I'm not technology anything.
That lead
My
bro.
Chromebook deleted all my stuff yesterday.
Really? All right.
What class? Which house?
You guys are very modest. This is a very modest classroom. People, very good students, very high ability, very well motivated, yet very modest, unassuming. The humble students they are.
I like that song.
Jose, did you finish, Jose?
What was that?
All right, Jose.
Paul C.
Let me see. Okay, so this one here, I'm gonna get the skinny pen. Okay, this one here, we got 13, so how do we start this one out?
Convert. Oh, X equals.
So what is our vertex is gonna be? What vertex is gonna be? 4, 3, right? So how do we start this out? F of x
So X equals A.
A.
equals A.
Whatever it's called.
Absolutely.
Absolute value X plus 4.
What is 4?
4. 4
What for?
plus 4.
Minus 4.
Minus 4?
Yes.
Oh, yeah.
That's 4, okay. And then plus 3.
Yo.
Okay, so that's the initial thing, and so what are we gonna do next?
Plug in
Plug in
Y for fx.
So plug in these, right?
Yeah.
So is that 2?
Yeah.
So 2 equals A times, and x is 0, right? So we're gonna put negative 4, is that right? Plus 3, and then, so we work that out, we get, what is this gonna be? Well, that's gonna be, that turns into 4, right? So 2 equals 4A plus 3, and then
Minus 3.
minus 3. So we get negative 1 equals 4A. So A is equal to what? A is equal to negative 1/4. So our equation, if it's right, should be f of x equals negative 1/4.
Absolute value.
Absolute value x
Plus 4.
minus 4 plus 3. And last thing we can do is check. So is that what you had so far, Jose?
Drop Jose.
Clear, so we go to negative 1/4 absolute value. Is it x minus 4 here?
Yes.
Yes.
And then plus 3?
Yes.
Okay, we'll see how this looks like. Graph. And then we'll check our points to make sure we have 0, 2, right? That's one of our points. That's one of them, that's good. And then 4, 3 we should have also. Oh, we got it, good. So this is like awesome work, right? Yeah, so we'll turn in today, so that really takes us to the end of class. Thank you, everybody, for participating. That was